Positive growth, positive decay, negative decay. These are the shapes that they take for any given function of that classification. So I made these up. Check it out. Number 13. Let's identify this as growth or decay. Look in the parentheses. Ignore everything else. Inside the parentheses, I have something that is smaller than 1 because the numerator is smaller than the denominator. If the stuff in the parentheses is smaller than 1 and the exponent is positive, we have a decay model. Now, is this positive decay or negative decay? The number on the outside is positive, so this is positive decay. How about here? So we cannot make a decision until the exponent is positive, as it was here. So what you'd have to do to make the exponent positive, make it positive, but reciprocate the stuff in the parentheses. And then you can make your judgments. So now that power is positive, now here this is bigger than 1, so this is growth. What type of growth? We're going to say that this is negative growth because the coefficient is negative. How about here? The exponent is negative. Make it positive. That is the first action that you take. Everything else stays the same. Now we can make our classifications. This is smaller than 1, and this is positive. So this is positive decay. So that's how you classify them as positive, negative growth or decay. What about the actual graph? Real quick, check it out. So the number in the very back is going to be your asymptote, whatever this is. In this case, 3. It'll be your horizontal asymptote. These are exponential functions. They all have a horizontal asymptote, namely the constant in the back, in this case 3. So I need to insert a positive decay model. What does positive decay look like? It looks like this, positive decay. So what we have is a positive decay model that looks something like this. Do they want you to give them a very precise graph? That's fine. Make a chart, X, Y, plug in, I don't know, like -1, 1, or how about -1, 0, and 1 if you want. You can plug in these numbers into a calculator and into one of these Casios. You can get your Y coordinates, you can sketch the graph. I'll let you do that. But the point is, know how to classify and know what to expect based on this chart. How about this one here? This equation has no constant in the back, so really it's just +0, which means that your horizontal asymptote, like dotted line, would just be the x-axis. Now, what kind of shape are we dealing with? Negative growth. What does negative growth look like? It looks like this. It opens down. So that means the graph would have to open down below the asymptote. It cannot open down from above because then it would cross that, and we're not trying to do that. But again, you could always make a table of values, pick some test points, plug them in to be confident with your graph. How about this one here? The constant in the back is -4. 1, 2, 3, 4. It's always somewhere on the y-axis, this constant. So dotted line at -4. Now a really quick graph. I need positive decay. Positive decay is this one. So it opens down like that. So positive decay would look something like, let's say like this, I suppose, like that. Okay. And again, if you want a more accurate graph, as I keep saying, make a table of values, pick really any, you can pick any value for x that you want, doesn't really matter, and rely on your devices for more accuracy. So what about a different concept? Just a quick FYI, 45, 45, 90, 30, 60, 90. In a 45, 45, 90, they call it that because those are the measurements of the angles. And in a 45, 45, 90, these are the legs and this is the hypotenuse. The legs are congruent. So if you call this W, this is W. There is a relationship between the legs and the hypotenuse. Whatever these are, you multiply it by square root 2. So that's why this would be all of W times square root 2. So if they give you the one leg, the other leg is the same. And whatever they are, times it by square root 2, and that's how you get the hypotenuse. For example, if this leg was like 5, then this leg would be 5, and the hypotenuse would be 5 square root 2. How about backwards? What if the hypotenuse is given to you? They say it's like 17 square root 2 or something like that. Then what you can do is remove the square root 2, block it out, and whatever is left over represents the two legs, in this case, 17 apiece. See what I'm saying? So keep that in mind. How about 30, 60, 90? Small, medium, large. This is the small, medium, large. So the small one comes from the smallest angle. That would be 30. The medium comes from the medium angle, 60, and that's 90. And there is a relationship between the 30, 60, 90. 30, shoot across, that's the small. Suppose you call the small like, I don't know, Q or whatever, it doesn't really matter. Then if the small one is Q, then the medium would be Q times square root 3. And if the small is Q, then the big would be 2Q. That's the relationship between the three sides in a 30, 60, 90. So let's say that the little guy was like 4, the medium would be 4 square root 3, and the big one would be 8. Let's change these numbers. What if they give you the large? Let's say the large is like 18. Then the small is half the large. Remember that? This is half that. So if the hypotenuse is 18, the little guy would be 9. And if the little is 9, then the medium would be 9 square root 3. So I always try to find the little guy, because then I can double it for the big, or hit it with square root 3 for the medium. How about this case? What if they give you the medium, and they say it's like 12 square root 3? Well, to go from medium to small, remove the square root 3, and what you're left with is the small, which would be 12. And if the small is 12, then the hypotenuse is 24, because he times it by 2. So that's how you play that game, but let's actually try it with some problems here. There we are. This is a 45, 45, 90, which means that the legs are congruent, so that means x has to be 4. And that has to be 4, and you hit it with a square root 2 to get the hypotenuse, which they called y. How about here? If that's a 60, this is a 30. Small, medium, large. What are you given? In this case, you're given 20, which is the big. So to go from big to small, divide by 2. That'd be 10. But which one of these is 10? The small one is 10. If it's drawn to scale, great. If not, identify the small as the side across the 30. If that's 30, shoot across, that's the small, which makes B 10. And then once you know the small, times it by square root 3 for the medium. So that means A would be 10 square root 3. Here, 45, 45, 90. The legs are the same, so whatever they are equal to each other, but I don't know either one. But I do know the hypotenuse. And I know how to go from hypotenuse to leg. I remove the square root 2, which means that each of the congruent legs is 7. One more. 30, 90, that means this is 60. What number are you given? Are you given small, medium, or large? Well, I'm given this here, and this is across the 60. So you are looking at the medium. How do you go from medium to small? You remove the square root 3, which means the small leg would be 5, which makes the hypotenuse 10. So n would be 5, and m would be 10.